Today on Building the Open Metaverse.
Games especially, they're designed to take you away. Like when you start playing a game, you are immediately in somebody else's simulation and you kind of have an assumption that the normal rules don't apply. Whereas if the metaverse is supposed to model reality, complement reality, augment reality, even though we might have, things that are different as kind of an essential attribute of whatever space you're in, we're still going to need to have kind of a baseline reality, I guess. And that's the piece that I think games don't really explore because they don't need to. Like they're designed kind of to give you a particular kind of experience. And so figuring out how do we actually make the base metaverse experience feel normal and comfortable, I think that's where we're going to actually have to do a lot of exploration first.
Welcome to Building the Open Metaverse, where technology experts discuss how the community is building the open metaverse together. Hosted by Patrick Cozzi from Cesium and Marc Petit from WebGL Games.
So welcome to our show, Building the Open Metaverse, the podcast where technologists share their insight on how the community is building the metaverse together. And today we're extremely fortunate. Our guest is Vladimir Vukićević, and his team at Unity focuses on enabling developers to bring content to a broad range of environments, including using cutting-edge technology optimized for both size and performance. What's also fascinating is prior to joining Unity, Vlad spent 10 years at Mozilla working on foundational web technologies and the Firefox web browser, and he is the inventor of WebGL. And what a credential, Vlad. We're so happy to have you. WebGL is the standard for high-performance 3D on the web, as well as the initiator of WebVR and R&D effort to bring VR capabilities to the web. So we're so happy to have you with us. Welcome, Vlad.
Thanks, Mark. Thanks, Patrick. Yeah, thank you for having me. I'm really looking forward to the discussion.
So, Vlad, it's such a pleasure to have you. Myself personally and Cesium, we're such big fans of WebGL, and we've really built all of our tech on that. To start off, we always ask all guests about, your intro, your journey to the metaverse, and as part of that, can you please include the WebGL origin story?
Absolutely. Yeah, I come from kind of a heavy open source background. I started working on the Linux GNOME desktop at a company called Helix Code back in Boston in the early 2000s. And so I've kind of always been interested in open source and kind of really enabling developers to have access to interesting kind of cutting edge technology. I ended up at Mozilla just before Firefox 1.0 with a passion for media. I wanted to give web developers access to video, audio, graphics, all of those things. Although back then the web was really, animated GIFs were kind of the new hotness kind of at the time. So WebGL especially really kind of started actually with Apple. Around the time of macOS 10 Tiger, I think, 10.4, Apple released something called Dashboards, where they included this canvas element. And back then, there was actually big uproar in the web community about how dare Apple extend the web and kind of do all of these things. But I saw that at Mozilla, and I said, hey, this is really cool. You can actually do programmatic graphics in the web browser with this kind of API. I set about kind of very quickly re-implementing a version of the 2D Canvas API. I think we shipped it kind of quickly after. And one thing that I don't get a lot of credit for, but I think actually is pretty important, is the original Apple API used kind of back then Apple-style, extremely verbose, add line to current path and, draw line to or move to point on current path methods. I really pushed to kind of make those be more of the, PostScript style, move to line to, so that we weren't breaking our keyboards typing all of that.
Well, thank you very much for that.
But you're welcome. Shortly after that, though, I kind of turned my sights to 3D. Like I always had a passion for 3D graphics, really kind of deeply interested in kind of both what you can do just for the visualization aspect and what you can do to actually create interactive experiences. And the thing for with Web 3D back then, I think the reason why I ended up doing it is because a lot of people told me it was impossible. I had a lot of people basically say, the web can never do 3D. This is really the slow, clunky thing that, it's never going to happen. And that didn't seem right. Of course it can. You got a programming language. It's slow at the time, but it'll get faster. And And so I, went ahead and gave it a shot. Back then, it was very hacky, OpenGL, P-buffers, all that stuff, 5 surface copies per frame kind of to get it rendering in the browser. But it worked. You had kind of the spinning cubes and you had some kind of textured things, and it kind of grew from there. And enough folks, both in the web community and kind of the graphics community, started seeing the value, started seeing that, there is actually something there. And of course, kind of at that point, the standardization effort began with Kronos, and folks like Neil Trevitt were instrumental in kind of helping kind of shepherd that along. And we kind of ended up where we are now, with WebGL available on pretty much every kind of computing platform there is, so that you can actually finally do kind of 3D on the web.
I mean, like a noob question, we have decent hardware on our phones and for the web on our PCs, but let's think about our phones. Do you think, how far are we from parity, like to have the same capabilities from within a browser like a native app? And what are there any steps or roadblocks that we need for us to get to that milestone?
Yeah, Mark, it's a great question. I think the biggest difference between any kind of web API and a native API is really security. Once you kind of have a native application running locally, all bets are off. They can do kind of whatever it wants. But once you are just a click away from who knows what, you need to kind of inject a lot of security constraints, which does impose a performance hit. I think we can get pretty close, though. I think there's a bit of a kind of a double-edged sword here, because I think the graphics hardware vendors and the driver vendors could implement some of these security constraints much more efficiently, but they would have to do it in a way that the browser vendors would actually be able to trust that. Because if you're a browser vendor and there's an exploit caused through 3D, in somebody's driver, it doesn't really matter who caused that. Your users are kind of being exploited. So it's kind of tricky. I mean, one of the interesting things is I think WebGL actually helped driver stability quite a bit. I think something like ShaderToy especially really drove fixing kind of a lot of bugs and issues that even games did. I mean, if you're shipping a game and the game crashes on various drivers, you're going to try to work around it because you don't want the users to have that experience. But if you're making a ShaderToy that works on your particular machine and crashes somebody else's, not your problem. So I think kind of the web has driven kind of a lot of that stability, but I think it's always going to be a challenge. I don't think it's ever going to get to kind of full parity, but especially with new APIs like WebGPU and such to kind of really bring things a little bit closer to the metal, I think we'll get much closer. I think we'll get to a point where it almost doesn't really matter. It'll be an insignificant difference.
Vlad, do you think those experiences will be written in JavaScript, or will they be written in WebAssembly?
I think that the web right now has a bit of an identity crisis. We see people talking about Web 2.0, Web 3.0, and things like HTML and CSS. This is kind of completely my opinion. I don't think actually have a place as the core of the web of the future. I think those things need to be kind of taken and put in a box that is your kind of traditional documented-oriented web. And we need to define a new web that is based on things like WebAssembly and WebGPU. We're going to lose some things there for sure. Like we're going to lose things like view source. That was one of the pillars of how the web got to where it is today. But honestly, we've lost that anyway. If you go to pretty much any site and you try to actually look at their source, it's useless for learning. It's useless for modifying. It's sort of this theoretical kind of nice to have thing that is lost, and we could gain a lot in performance and capability by boxing kind of some of that old technology away and really focusing on the future. The other aspect of that is I think the web today, it's very complex. Like if you wanted to start creating a new web browser today, you can't do it. Like there is no way to have enough of an investment to create a web browser from scratch. And I think that is a massive, massive negative for the web because it completely stifles competition. Like nobody can try to do anything better, faster, different. You're going to spend all your time just trying to catch up to the current state. And if you don't do it perfectly, then nobody's going to use your tools because they can't actually participate in the web.
Do you think WebAssembly makes this problem easier, or that barrier to entry lower or higher?
I think WebAssembly makes the problem easier in that you now have access to a wide range of programming languages, some of which are going to be simpler, better suited, like whatever kind of capability you're looking for, you now have choice. You're not kind of stuck with just JavaScript with its pros and cons. So I think it makes kind of the barrier to entry easier kind of for developers and for folks that are trying to create a new browser or kind of a new way of accessing the web. If we can find a way to kind of actually sandbox things like HTML and CSS and whatever else, then maybe we could use some of the current engines essentially in that box. Like you have your HTML rendering engine and it lives in that box, but you get to innovate on the WebAssembly side. You get to innovate on performance of WebGPU and integration and all of those pieces, which is where I think a lot of kind of the rich evolution is really going to come from.
So Vlad, if I'm a software developer and maybe it's a few years from now and I'm thinking about making an immersive 3D experience for the metaverse, I mean, what do you think the trade-offs are going to be on, am I targeting native? Am I targeting web? Am I targeting both?
That is a great question. I think we would have to kind of figure out what the metaverse is first, because the metaverse might actually not have any native software. It might all be something like WebAssembly modules or whatever else. On the flip side, it might actually be all native software, where it is, a single environment that you run on whatever device you have, and you have a kind of walled garden, limited experience there. I think that we need to figure that piece out first, and what's likely going to happen is we're actually going to have all of those options. So I think if anybody wants to make an immersive experience for the metaverse, pretty much anything that they pick today will likely be relevant or fit in some niche over the next few years. It's going to take a while until we actually settle down on a particular model that actually really works for kind of creating the environment that we want. And I hope that we do actually get to explore all of these areas. I hope, somebody does try to build, the all-in-one metaverse that is a single native app, and somebody tries to build the fully distributed, everything dynamic, downloaded, everything metaverse as well, because we need to try kind of every spectrum in between.
Are we seeing games developer give WebAssembly a try and try to create, the one-click away game that's a decent, interactive experience?
We are. The holy grail kind of for a lot of types of games, especially mobile games, is, for user acquisition, that kind of, one click and you're immediately kind of playing the game. The tricky part is I think we don't quite have the right development model to make that possible. Pretty much all of our engines today involve some kind of large asset download, then, large startup to kind of set up everything, and then, just basically doing a lot of work up front kind of to get to playing. One of the things that I was working at Unity previously to focus on Lightweight XR was something called Project Tiny, where we were trying to use some of our data-oriented approach to really reduce some of those initial things. Like, what if all your asset data and your scene data was pre-processed in a way that you could just load it into memory and just go? Turns out you can get kind of fairly far with that approach, but it does require a shift in how you build content. And so there's kind of a tricky problem there where, in general, developers really want all the richness of current engines and all the capabilities, but they also want that kind of instant startup and speed that you would only get if you could actually switch models.
So how small, let's geek out a bit, how small do you get Project Tiny? What's the smallest footprint you got for Unity right there?
So, yeah, for Project Tiny, we were targeting fairly small-scale games, so kind of think, instant games and such. But we had, little multiplayer kind of kart racing games and things like that running in about 500 kilobytes of compressed WebAssembly, JavaScript, and such. So pretty small, and also kind of pretty fast to download. Like, we actually did get to the, literally tap a link on your phone and you're playing a game, within 1 or 2 seconds. But it had to take a lot of constraints to get there. And some of those constraints are not really the ones that users kind of really wanted.
We're running game engines, as you know now, in vehicles on a very, very low-powered hardware platform with a lot of security constraints and stringent performance requirements. So I think it's a very good exercise to try to shoehorn some of our technologies there. I think we're all learning a lot in this process. So.
Absolutely, and I think kind of those learnings are really going to translate to the metaverse, because we have the same kind of constraints and requirements around security, around instant access and everything, that and also actually around low-powered devices. Depending on what way we're using to access this, especially when we talk about kind of augmented reality, that should be kind of an all-day type of experience. And so power consumption and all those things become extremely important.
100%. I think it's fascinating the amount of work and problems that we still have to solve to deliver that architecture. When we were talking with Bill Vass, we kind of double clicked on that. The various layers that we're going to have and how we will need to connect them and kind of distribute, the compute load amongst like a very low powered wearable device like glasses or even a watch, and then a phone that has a little bit more power, a little bit more battery and more graphics, and then the edge, and then the big scale, and how much work is there going to be for us to basically create a unique experience that spans all of those layers at the same time. So is it something you see that the web could be actually, and the WebAssembly, web architecture could have a leg up in creating those layered environment and hybrid approaches?
I think WebAssembly will definitely play a part in whatever kind of future metaverse we end up building. I think as far as kind of the hybrid approaches go, though, that is going to be a model that we need to solve, but we need to figure out how to make that accessible to developers first. It's hard enough today to make a multiplayer game. I think we would close the door to many developers, many new developers, if we started telling them, well, you have to become distributed systems architects first, and then you can, build kind of whatever the thing is that you're creating. This is one of the areas that actually really excites me, because we're basically going to have to figure out a new way to develop software. We're going to have to figure out a way that those kind of transitions, like those layers, are just a natural way of how we develop, where maybe it doesn't matter, or maybe there's a natural way to transition things from your wearable to your phone, to the edge, to the cloud, connect to bigger simulations, whatever kind of the use case is. But if we can't make that accessible to developers, it honestly doesn't really matter how powerful it is, because nobody will use it, or it'll only be used by a very small set of people.
So do you want to talk about open standards, Patrick?
I love open standards. So Vlad, first, look, thank you again for joining us for the SIGGRAPH Building the Open Metaverse BOF that we held this past SIGGRAPH conference. Pleasantly to my surprise, a lot of that BOF ended up being about open standards and building an open and interoperable metaverse, and what standards do we have and what standards do we need. And I thought it was really interesting when you were talking about 3D assets and kind of the segmentation of assets, attributes, and behaviors. And I was wondering if you could go over that in a little more detail and also share kind of what you think about what standards we have today that may work for 3D interoperability in the metaverse, and then where you think the gaps are, what we need to fill.
It's a little weird for me to talk about standards kind of at this point, because it's definitely kind of tricky to think about standardizing things before the thing actually even exists. And it can be a good way to almost stifle some of the creativity that might actually come out of a much kind of free-ranging exploration. I mean, if you think about even kind of 3D on the web, there was VRML well before WebGL was a thing, but it kind of died out, and it was designed kind of very much this sort of standardsy, very heavyweight, process that seemed to be maybe popular in the 90s. But when I think about kind of what I think at least we're going to need kind of in the metaverse, during SIGGRAPH, I mentioned kind of we've got assets and then kind of attributes and behaviors. What I meant was, right now, a lot of the focus in the metaverse is really about assets. Like people kind of ask, like, well, if I get a sword in one game, how can I take that sword to another game? In the back of my mind, though, what I actually hear kind of like the background question is, well, making a game is really hard, and I want to make money off making games. So I would really love it if I could actually just, open up a ye old sword shoppy and start selling swords for $10 that people could take to any game they wanted. I'd make a bunch of money without having to actually invest in making a game. So I think kind of a lot of these, like, how do we actually move assets from one game or another is kind of an economic question. Like, people want to actually start businesses on just selling those assets. I don't know that that's actually that interesting of a question, though, because getting a mesh model from one environment to another, it's hard. I mean, there's work and things involved in pipelines, but it's not impossible. It's just kind of, okay, but to what end? Okay, now you have kind of this model. Like, what does it actually do? That's where that second piece around kind of attributes and behaviors kind of really comes in, because I think those are going to be the building blocks of whatever metaverse we end up creating. So, for example, for attributes, let's say I've got a torch that is obviously hot and has kind of a light source, and then there's a block of ice with some item or something embedded in it. If I was making an adventure game, I might say, well, if the player applies that torch to the block of ice, the ice melts, I get the item, everybody's happy. But if you think about kind of the relevant pieces there, well, the block of ice is meltable, the torch is hot, and if you combine something that is hot and is meltable, that meltable thing melts. And so if we use kind of very simple building blocks and use, at a very massive scale, maybe we actually get some of these kind of emergent behaviors where now if you have this behavior of anytime a heat source is applied to something that is meltable, it melts, you get to reuse that kind of pretty much anywhere. And by building up kind of this rich set of attributes and all these things, we also get to, inject new behaviors kind of by user choice. So, for example, that torch is also a light source. And maybe what I actually want is a behavior for whatever reason that whenever a light source gets near something that is cold, it becomes brighter. I can inject that as a behavior into the overall simulation. Maybe it actually only applies to me and kind of to my components. And everything that is a light source, everything that is cold, all of these kind of things just automatically kind of fall into it. And this is kind of it's a pretty kind of low level, almost kind of a very kind of simple rule set based approach. But I think we have the simulation power that we can actually expand these rules out kind of pretty massively. And we might get to something that will let us actually model some of the interactions that we see in the real world. Like that realism is really what's going to make the metaverse real. Like it has to kind of have some of these kind of very natural feeling real world interactions. And that's why when do you think we could? You could codify the world into a finite number of those behaviors, like kind of break down a simulated worlds? And actually, I was thinking about it. Probably. Yeah, I agree. I think probably. I think it would be a significant effort, but maybe not if you actually distribute it. Like if you actually distribute the effort, if everybody contributes some piece of kind of realism to whatever this massive metaverse simulation is, maybe you could actually get there.
So, Vlad, on that note, and going back to, kind of moving fast versus standardizing and when do you standardize? I mean, how much do you think we, the developer community, know now versus what we need to explore, right? If you look at kind of all the decades of making games and what kind of widely used attributes and behaviors may be there, is this just a lot of research and compiling, or do you think there's a lot of new exploration before you may be able to make a pragmatic standard?
I think there's definitely going to be a lot of exploration still needed, mainly because games especially, they're designed to take you away. Like when you start playing a game, you are immediately in somebody else's simulation, and you kind of have an assumption that the normal rules don't apply. Whereas if the metaverse is supposed to model reality, complement reality, augment reality, even though we might have, things that are different kind of as kind of an essential attribute of whatever space you're in, we're still going to need to have kind of a baseline reality, I guess. And that's the piece that I think games don't really explore because they don't need to. Like they're designed kind of to give you a particular kind of experience. And so figuring out how do we actually make the base metaverse experience feel normal and comfortable, I think that's where we're going to actually have to do a lot of exploration first.
We mentioned, we had Neil on the podcast talk about, USD, an authorable format, gltf, a way to distribute format, and it's interesting to discuss about those behaviors because, do you think like a standard like gltf has the potential to start, undertaking that effort to standardize those behavior and then grow those, like what we were discussing with Patrick earlier, like grow from static objects to kind of smarter objects with some simple behaviors to more smart objects, and eventually to grow gltf into the way to interchange like simulated worlds almost. So do you think it's kind of a logical path for us to pursue as an industry right now? Or does it take a rebuilding from the ground up of something new?
I think it's interesting. I mean, I think any of the extensible formats, so GLTF, USDZ, even FBX and such, has the potential to grow because they are extensible. I think the risk is trying to kind of standardize that extensibility too early, but it's sort of a mix because the opposite end of that is somebody extending it very privately and ending up with kind of that walled garden metaverse. So ideally, what I hope that we get to is a lot of companies, individuals, really whoever, experimenting with a bunch of these areas, but really doing it in the open. Not trying to kind of recreate that walled garden that we somehow ended up with in the mobile ecosystem on the metaverse. Mainly because I think like that approach is going to fail. Again, just that baseline kind of reality, it needs to be kind of accessible to everybody. It needs to be shared. I mean, look, if let's say Patrick, Mark, let's say both of you came over to my house. Patrick, you had glasses from Samsung. Mark, you had glasses from Facebook. I had glasses from, Microsoft. I just bought a AR board game, and we want to play together. That needs to be an experience that just works. That needs to be something that is effortless, frictionless, kind of thoughtless, really. And if it doesn't, I think we will have kind of failed as an industry to actually really build kind of the true potential of this. So, at some point, kind of open standards and such are going to be extremely important to allow something like that to happen, because obviously everybody has to agree kind of on something. But the path to get there, I think, is going to be a lot of exploration, a lot of dead ends, and, a lot of... just a lot of work, really.
Since you're an XR expert, do you consider OpenXR to be a success right now and kind of a model of us as an industry coming together, or how do you look at OpenXR?
I think OpenXR has been pretty successful. I mean, I think a lot of the kind of the industry coming together around it has been relatively new, but I think it is a good model for kind of providing, after some number of years of exploration and vendors taking different routes and different approaches, coming to an understanding of like, oh, okay, these are actually the common pieces. These are the things that are relevant. These are things that are unique. How do we actually define a way to simplify life for both of them and also for developers? Nobody really likes to maintain their own API if you can, jump in on somebody else's, but it takes a while to figure out kind of what you actually want. And that's where you have to have the flexibility to experiment yourself.
Vlad, I really like this experimentation in the open. I think that's a key concept, and that will help us eventually converge when people can see what each other is doing.
So you when you introduced yourself, you talked about lightweight XR. So can you explain to us what lightweight XR mean and what it really entails?
Sure. Yeah, so I mean, the lightweight XR effort in Unity is really trying to figure out kind of some of the things that we've been talking about throughout the podcast in terms of, these future XR experiences are going to need to be instant. They're going to need to be potentially distributed, lightweight. How do we actually do that? How do we as Unity do that? Unity is really designed right now for a very immersive experience. When you're running a Unity-built game, or really actually any engine out there game, it expects to take over your entire device, all your CPU, all your GPU, your entire display, everything. That's likely not going to be the world that we're going to be in the metaverse. I'm sure there will be kind of fully immersive experiences, but there's also going to be a lot of shared experiences, kind of very contextual experiences, depending on location, time of day, like whatever the thing is. How do we actually enable, for Unity at least, how do we enable our creators to have access to create those kinds of experiences? That's the kind of stuff that my team is really exploring, kind of to figure out kind of what is a potential path to get there. Because, yeah, like I said, I think we're going to be interacting with a lot more of those types of experiences in the future, and the kind of the fully immersive ones will absolutely still be there, but they will be sort of like choosing to go to a movie as today versus, just kind of living out your regular daily life.
I agree. I mean, we expect to live in a world when every glass panel is potentially a screen where digital content can be displayed. So we'll have to scale from super low power, or lightweight experiences all the way to the big heavy duty immersive stuff.
So Vlad, as you're looking to kind of optimize the XR experiences, I mean, how much of that is VR specific, AR specific, or just XR, that will impact both of those?
Yeah, that's a good question. I think the first metaverses that are likely going to be built are probably going to be actually VR experiences. I think that's where the hardware is available and of pretty kind of good quality right now, that you can experiment with a lot of the other factors, whether it's the instant startup, the security, safety, dynamic, distributed, all of those pieces. So VR, I think, is going to have kind of a pretty big part to play. But AR is where I think we all ultimately want to get to. Like, we actually want to get to that augmented reality world where we have some way of actually augmenting our life. So I think kind of a lot of these experiments and explorations are really going to happen in both, and they're really going to benefit both, especially when you think about things like power usage and whatnot. A lot of the VR devices like the Oculus Quest, it's all battery powered, so any improvements that you make there will definitely help.
So I do think as those lightweight XR experiences, isn't that the role of the web? I mean, shouldn't we expect the web to be delivering those lightweight experiences and kind of reserve the bigger engines for the more hardware demanding environments?
Possibly, but if you look at the web as something that is kind of just another universal platform, right? If we take the HTMLs and the CSSs and kind of shove them away, then I think the web just becomes another target. And I think kind of all the engines really should have a way to get to the web in a meaningful way, in this future web at least. So, this is likely that WebAssembly plus WebGPU plus WebXR plus kind of whatever portion of the web. The one advantage that I think also a lot of the bigger engines have is really the authoring environment. The web is a pretty great kind of distribution medium, but I think the reason why people come to Unity, come to Unreal, come to others and say, hey, we want to get our content to the web, is because those tools are good at actually creating content. The web doesn't really have anything equivalent. It's a great kind of distribution and publishing medium, not a great authoring medium.
So I have a history of being involved in investing in browser-based tools when I left Autodesk in 2012, and it was hard. So I hear you. I'm still hopeful that we'll see, investment, and I think that there's improvement in architecture that that's going to help play back 3D content on the web. I'm hopeful that we start to see better tools. I was actually surprised to see Photoshop running in the web last week.
Yeah,
and I think it's interesting to think about as well. Building better tools inside the browser, just also for the same level of convenience. But I hear you that you don't want to author content from one platform, so it's always going to be safer to author that content into a tool that is known to cut across a lot of publishing platforms. So.
Yeah, I'm actually not even sure that authoring is going to look the same once we actually think about the metaverse. Like all those same things that you described earlier, Mark, around the distributed capability and kind of having to layer content execution. I think the same thing applies to authoring. If we look forward 5-10 years from now, whatever the metaverse looks like, the creators then, they're going to want to create while in the metaverse. They're not going to want to sit down in front of a, computer screen and open up an editor and kind of do all these things. So we're going to have to do a lot of transition work even on the authoring side. And that's where I think, the web or kind of web instant delivery models absolutely have a part to play in kind of just making some of that broad accessibility really be possible with those tools.
Yeah, in-place editing, especially with AR. I mean, because virtual thing will have a location in the world, right? So you probably want to tweak them when they're supposed to be. So that's going to be
absolutely
a lot of fun on the horizon, Patrick.
You mentioned kind of in-place editing. The other aspect that I think of the metaverse that's going to be super important is users need to kind of own their own metaverse. So we talk about kind of people authoring and, in-place editing of, content and whatever else. I want to be able to, as a user, in-place edit effectively kind of my own reality. So everybody's going to become an author in some way. And I think that's going to bring with it kind of a whole new set of challenges. So yeah, absolutely. A lot of fun, exciting stuff on the horizon.
And hopefully a new economical model when people can actually make a living and have a fair split of the value created between platforms and creators and everything. So I think, it feels like a pivotal moment, and where it's our responsibility to lay those foundations for the next wave, next generation of the internet.
So Vlad, we've covered a lot of ground today, right? From WebGL to the future of the web, to standards, to lightweight XR. What didn't we talk about that you'd like to talk about?
I think one thing that would have been fun to dive into is some of the stuff that I'm doing on the side. I've started lately exploring a lot of kind of ultra-wideband positioning kind of systems and such, because I think that kind of hyper-local location is going to be, obviously kind of a key part of any kind of future metaverse augmented reality stuff. So I've started building out a little UWB localization system kind of here in my home office. Going to be extending that out to the entire house at some point in the future. I just kind of really get an early glimpse of what things might be kind of once we kind of get to that future.
What kind of accuracy do you get with the positions there?
Ask me after I install everything over Thanksgiving week. That's the actual installation is
so
coming
what's your
up
prediction?
soon.
What's your simulation telling you?
Prediction, and I mean, honestly, from talking to some of the folks that make some of the devices that I make, should be within 10 centimeters, which is not amazing, but it should be kind of good enough for some of the stuff that I want to do. And it should be good enough to at least get a kind of location fix for static elements in the room, like, where the thermostat is, where the stereo is, where that kind of stuff is, so that when I bring my phone close or bring some other kind of device close, I can actually get some of that contextual interaction there. But first step is get the hardware installed and get kind of everything set up, and then feeding into some kind of likely Unity simulation. And then actually start exploring some of the stuff we've been talking about. How do I actually get a dynamic interface for my thermostat or for my stereo through this environment? So it's going to be fun.
Great. Can you make sure you write a Home Assistant plugin? I'm a Home Assistant addict.
Likewise, yeah. There might actually be something there, so I'll make sure to send you an email.
And the other curiosity is, what kind of hardware are you playing with to achieve that?
This is right now just some kind of experimental hardware. Once I started looking into this, it led me down to some contacts with some folks on the web. There's, as you can imagine, a number of startups that are really kind of exploring this right now. And they were gracious enough to give me access to kind of some early hardware. I'm not sure if they would be okay with me mentioning their name, so I'm kind of a little hesitant there. But it's some fairly small devices, fairly low power, also relatively inexpensive as well. So I think that there's going to be something here kind of for folks like us who, automate everything through Home Assistant and such. I think we'll have something we can set up in our houses within the next few years to get some of this.
You win the prize of the geekiest of the geeks so far on the podcast. I mean, that's pretty ultra-wideband positioning. That's pretty hardcore. Congratulations. Any organization or person that you think you want to give a shout out at during this conversation in this context?
Yeah, I mean, I think, WebGL was definitely not kind of a solo effort. There was a number of folks, including people like Ken Russell and Neil Trevitt and a bunch of others who really kind of helped kind of shepherd it. But I think the one person that really made 3D on the web incredibly successful today is kind of the author of 3JS, Ricardo Cabello. Like, I think without him, it would be just the OpenGL API on the web. But 3JS really made it accessible to web developers, like people that didn't have kind of a 3D background. So I think, where WebGL and really where 3D in the web is today is owed to him, I think, in a very, very large part. So big shout out kind of to him. And I think it's, the 3D would definitely be a different kind of environment without things like 3JS.
Yeah, and I'd give a big +1 to Mr. Dude, Ken, and Neil. And by the way, they all have something in common, which is they are fantastic community builders as well as technologists.
Yeah, 100% agree on 3.js. It's been a fantastic foundation for many new companies, actually, many new businesses. So it's fantastic. All right, I think we've covered a lot. Vlad, I want to thank you for being there with us today. And we have to do the regular, if you like this podcast, hit whatever buttons you have to hit subscribe. If you like to geek out, please come back. And if you have suggestions for people we should welcome on this podcast, please submit it to them. But Vlad, it's been an amazing conversation. Thank you so much for being with us. Hello to all of our friends at Unity. And Patrick, I leave you the final word.
Well, thank you, Mark and Vlad. Yeah, it's been inspiring and forward-looking, and thank you once again.
Yeah, you're welcome. It was a great conversation. Thanks for having me.